begin our class. Time has gone, and we shall just admit those who are just coming in, but they're late already. You started late at 8:30 because I wanted to give you time. It was too early to begin the class before you are ready for it. Otherwise, I'm fine. I'm doing well, and I hope all of you are also doing well. Wherever you are, feel welcomed so that you can share and do something at least for this first class. Mr. May, Moses, are you there? Mr. May, can you
Yes,
get to
yes,
me?
I am. Yeah,
Okay, super, good.
yes,
Karibu sana.
yeah, we are getting.
Okay, let's look at the cost outline. The cost outline is some people are still joining. I don't know. They are giving us a lot of interruptions. Okay, this is FEE412, which is Control System B. You know about that unit, the fourth year unit for this semester two. The unit outcomes will be by the end of this course, students will be able to differentiate between dynamic and static loads and the application as far as control is concerned, to be able to understand and apply Newton's law to mechanical systems, thermal systems, hydraulic systems, pneumatic systems, and electromechanical systems. So Newton law of motion, I think. How many are seeing what I'm presenting? How many are seeing what I'm presenting? Nobody. Let me just stop presenting, then I start fresh. Okay, are you seeing it now?
Yes, thank you.
Yeah, I was talking about the cost outline for the FEE 412, and it's talking about the control system B. And this area of study will be looking at the certain objectives that must be covered, the five objectives. By the end of this course, you'll be able to differentiate between the dynamic and the static loads and the applications in the field of engineering. You should be able to understand or be conversant with the Newton law or to mechanical systems, thermal, the heating and the hydraulic, pneumatic, and the electromechanical systems. Understand and apply the working principle of gear, trades, considering power matching based on load and motor characteristics. Design and P, the proportional integral, and proportional integral and derivative controllers, and appreciate the application in the industry. Then understand and appreciate the role of digital computers as a control element to digital processes, the digital process. So topics will run from week 2, and week 2 will cover what is the objective 1. Then week 3 and 4 will cover the electromechanical systems, pneumatic and hydraulic systems. Then we shall also go to week 5, let's talk about gears, which will talk about the mechanical gear traits, power matching based on load and motor characteristics. Then we shall do maybe a cut somewhere, we shall think about it. Toward the middle of the semester, we shall look at the amplifiers, electric, electromechanical, pneumatic, and hydraulic amplifiers. So these things can also be amplifiers for the control systems, mechanical systems, and pneumatic systems are applicable. In their model, we model them to become amplifiers. Then we shall look at the controllers, the PI, D, and I. Then the instrumentation of the system. Then we'll just look at the standard systems of analog to digital, then digital analog converters. Okay, attendance will give you a mark of 5%. Anything you're doing in class will give you 15%. Then cut maybe 10%, but probably 70. I'll send this thing to the class rep so that you can get it straight away. So look at the references. Any question based on the concept line? Okay, now we just want to look at the physical systems and how they look like. They look like in modeling. I think if you talk about physical systems, we talk about loads and majorly these loads in control system, we shall look at them in terms of the Newton's law, the Newton laws. Newton has 3 laws, law 1, 2, and 3. So we shall look at them now. They're working, but mostly in the control system, we shall do the representation. We represent physical system or components, and the way of presenting systems. Let me just admit somebody here. Wow, what's happening? There is one way you can present physical system. You can just do direct. You can just do direct the analog type, direct analog presentation. You can also do graphical modeling, graphical modeling. Or you can do mathematical modeling. So majorly, before we go to what we want to do, can explain that the direct model, the direct one, is just maybe uh, the analog system. It's just drawing, maybe using you you just maybe do something and make the system in its dimension, and use it the way you want to use it to do the test on how it can work, and you just go direct and see how it works. Uh, this is just like the power system network. You can just do the normal dimension of the power system, a network of power system, and you do the correct configuration, and maybe run this simulation. That is also modeling, like you run a certain standard network system developed by maybe the IEEE, and you use it now as a model to do your simulation. That is analog type. Then you can also have a graphical representation, graphical modeling, whereby you use a block diagram and through that block diagram, you can show how the system operates. And lastly, the mathematical modeling. The system is investigated on various parts of it, on various parts, and these parts have a mathematical representation or equations or variables useful for equation, useful for the general equation. This is a man majorly applied in control system, use mathematical model to investigate on various components of how they interact, and in practice, the parameters will give us the nature of how the system operates, the difficulties that are involved, the effects, and we make it much simpler to see that the system works properly. Otherwise, I'll take you through some kind of slide to see some of the models, the kind of mathematical physical models. So normally the introduction to control system is a must because it is what is supposed to be done. Then you see the modeling and let that first function. I think you've done control system one, but now for us we're just going to do something different, which is so the more you learn, I can see this. You tend to move to learn and to see much. So control system is when a number of elements are combined together to form a system which produce desired output, then the system is referred to as control. When a number of elements are combined together to form a system to produce a direct or a desired output, then the system is referred to as control. It doesn't matter whether the system is either doesn't have parts to move, but if there is something that can have inputs and the outputs are desirable, then it means that these units are working together and they are controllable. The main features of control system is that there should be a clear mathematical relation between input and output of the system. So there's no control system without a mathematical relationship between the input and output. It must have. So when the relation between the input and output of the system can be represented by a linear proportionality, the system is called linear control system. Again, the system used for controlling the position, velocity, acceleration, and temperature, pressure, voltage, and current, etc., are examples of control systems. So any control system is designed to control either the orientation of the plant, the movement of the plant in terms of speed and acceleration, even the temperature, the heating, temperature of the room, temperature of the boiler, temperature in the factory, the pressure. If these things are not controlled, actually, you expect to have a disaster. So control is a way of looking at the output is not going outside the requirements. So we also have open loop control system and closed loop, you know that. So interconnection of elements and differences for design purpose. So system is just interconnection of elements. Then control system is in interaction of components forming a system that will provide a set. The process is a device, plant, or a system under control. The device, the plant, or the system under control. So the input and output relationship represent the cause and effect. So input is the cause, and output is the effect. So there's a cause-effect relationship, input-output relationship. So there's something working within this black box. So control variable is the quantity or condition that is measured and controlled. Normally, control variable is the output of the control system. So the output, you have a control variable. Is it the position you are controlling? Is it the speed? So speed becomes the control variable. Manipulated variable is the quantity of the condition that is varied by the controller, so that to affect the value of the control variable. So you must deal with this another variable and give it some kind of manipulation, maybe based on controllability. Therefore, if it's really controlling, then we shall have variable output there being controlled. So you'll see that there is in the input of the control system there's some kind of mathematical measuring or addition or some multiplication. So it measures the value. The control means that the measuring of value of control variable to the system and applying the manipulated variable to the system to correct or limit the deviation of the measured value from the set value. So there's kind of measuring taking place so that the variables which are applied to the system can be manipulated to give us the correct deviation so that we can have a set value. So you'll see that the input sometimes is called the set point or reference. The controller is a major thing that is being designed, and the output from the controller is manipulated so that it can also work with the process. Because if it is a digital kind of a plant, then the controller will have to change the system, the input which was not digitized to become a digital component so that it can be able to interact with the system or the plant. If it is analog, plant is analog type, then the controller must be having a system that can convert this input to analog type so that it can work with the process and give the output. So whichever comes to the process must be in a relationship, must be in tandem with the process. You cannot mix things which don't work. They must agree. Like you cannot count animals in terms of it, okay, if you have sheep and sheep, goat or sheep and cow, they cannot be mixed together to give a process. Something must be done to make them look similar. So that is what is the controller does to manipulate the variable and make it work with the plan. Now, as much as we are working on within the system, sometimes we have a disturbance. These are the unwanted inputs to the system, and sometimes it can be generated within the system. So we call it a disturbance. While anything external is being said to be outside the system. So this one you have gone through the open loop, because loop you know it. So that one should not worry you. So just maybe to mention in passing, open control loop system is this is we always say that it is a stable system, but the output has no effect. The output has no effect on the control action, no feedback. So once something has left, your bit has been controlled. The process it cannot be controlled anymore. Like shooting a gun, you'll aim at the person or the target, but once the bullet has left the barrel, you have nothing to do with it. But a missile can have a feedback. It can be fitted with a control device within it. And those who launch a missile can still control it because they will measure the direction it's heading to and proportionately control it so that it can hit the target as required. So if there's any feedback from the data sent by the missile when it is being launched and it's gone, then it can be manipulated still because the feedback will be sent and manipulated and sent back to the signal data. And of course, that one is now closed loop. So some of the some of the open loop systems are electric hand dryer. Once they are working automatic washing machine. Washing machine is also open loop because you can never tell whether the clothes are clean or not because you don't measure that. But you just run up to the time whereby it has been given the setting, and after setting, it will be just gone. It is you to look at the clothes when they are washed and say, these things are not clean, let me take them back again. But if you have a system that can check whether the system has been washed properly, the clothes that is, then that system becomes closed loop. Red duster, time-based cloth dryer, volume of a serious system. So since an open loop control system reference input is not compared with the measured output, reference input, there's a fixed operating condition. So let us not dwell so much on that. I just told you that in the closed loop also, the feedback is taken back and measured and compared, then it's supposed to give us. If there is a zero, if you feed and the comparison is almost zero, then there's no process. This process is normal. But if the output is against the reference, then you have to controller has to work. Controller has to do something. to make the process run as per its high. And therefore, just like a vehicle, you have a steering. If it is not going the direction you want, you'll be able to see. Then you know where you're going. The road could be, the road is the reference. The direction of the road is the reference. Then you compare with what you've seen, the steering. Then when you know that it's now supposed to meet the road, there's no deviation from the road direction and yours, the steering, then control. You just, you manage the vehicle. You just compare that to, and within the vehicle itself, the wheels run according to the process, the technology involved, then the vehicle just goes in the direction required. We also have a temperature control system whereby you have set maybe the temperature be 23 degrees centigrade, which is room temperature, or maybe it is very cold, so it's 40. Then you have the aircon in the house. So the house is the one which you want to heat. The aircon is the one which has a temperature and the heater. So there's always a heat loss within the system, but it is manipulated also to have effect on the house. So if the temperature is 40 in the house, then it is taken back. So 40 minus 40 is going to be 0. So the aircon may just be not working because the switch for that is now off. But if the difference is there, and it is digital kind of, we are value, digital value, it will switch on based on the speed you want it to run, and you will be able to cool the house. So the manipulation is just what is it that is going to be the error, the reset, the error here which is measurable is the one is going to either send a signal. The signal, these days things are more or less using technology that is more digital. So to give a value, that value should be able to give you the quantity of air required. Then the air will be working with the house, cooling or heating. The float valve in the washroom is also a control system. There's one which is used that is more open loop, closed loop. The float height will depend on the sun water level. The flash will empty the tank and to lower the valves and opens for water to come in and enter the tank. The float now turns back to the sun level and the valve closes. So what is being controlled here is the water level. So I decided that the water level should reach some level. We have set it, okay, in that float height. So we expect the actual level to be the output, which is set here. So flash, somebody comes and flash, it will be empty. If it is empty, the float will indicate that the desired level has gone down. So the same float now that it will open the if it is down, a switch will be opened so that the valve, the float will open a valve, okay. The float is connected to a valve and the water will flow to the tank to give it actual level. So when there's a flash, is fed back, and everything works for the work, and it works like that. So modeling of physical systems, that's where we start with. The control system can be represented with a set of mathematical equations known as mathematical model. These models are useful for analysis and design of a control system. Analysis of control system means finding the output when we know the input and its mathematical model. It's finding, analysis means that you find the output when you know the input and its model. Design of a control system means finding mathematical model when we know the input and the output. Design of a control system means finding the mathematical model when we know the input and the output. So, if someone wants you to design anything, it must give you the variables. You must know what you are designing. You must be given the actual values. So that now you set the apparatus and the equipment that are supposed to give you those values. That's why we started looking at various types of systems which are supposed to be in a position to give us the models: hydraulic systems, thermal systems, electrical systems, mechanical systems. So that my design will be developed, will be working with these components, our machines or apparatus. The following mathematical models are commonly used or mostly used. Differential equation model. Sometimes when you do differential equations in year 2 and 3, you think that it's mathematics people are giving you problems. But no, they are giving you foundation because they know the load you're going to carry up there will need them. So you can use differential equations, the transfer function model, or state space model on mechanical system, electrical system, thermal, hydraulic and chemical system, pneumatic also. A mathematical model is a set of equations, usually differential equations that represent the dynamics of a system. In practice, the complexity of a system requires some assumptions in determination model. Yeah, you have to assume there are certain effects. I'm not referring to this now. I can just explain as you listen to me. Because I mean, some systems are linear and some are not linear. And if they're not linear means that the input and output are related in a straight line. If inputs increases, the output increases. So the work, if the input decreases, the output decreases. So they work in tandem. They are related. But some are not linear. Sometimes the input is increasing, but the output is going down. And at some point now, there are certain very small effects which are negligible, and they cannot bring any change, but they are there. We can mention them. What about this? When we say it is negligible, so we sometimes we what to do if they bring some complexity, you take some assumptions, and sometimes you neglect them just to help us determine the model. So physical parameters are always assumed to be constant for time variation. Physical models are not assumed to be constant with time variation, which makes the coefficient of the system equations constant. We always assume that systems are constant. The cause and effect will alienated and are constant, and therefore we assume it mathematically that it will not affect the system, anything. Uncertainty, like noise in a system, are neglected, which avoid statistical treatment. So for you to analyze some of these things, it will mean that you don't complicate it but make it much more simpler. So how do you obtain equations? The physical laws of the process, which now, if you start with mechanical systems, we shall look Newton laws. Electrical systems, will give us the Kirchhoff's law. The basic types of mechanical systems, which is translation system, whereby we have the spring, the mass, then the dashboard, the force. This be, like a vehicle has a general spring, the spring of the vehicle, and the shock absorber, then the vehicle itself, the mass. So when this force applied, everything there has to come into effect as control components. We are not putting these things for the sake of putting them. We are designing a control component that when there's a weight acting on some certain, maybe if it is lying on the ground, like so, there's a vehicle here, there's a road here, the wheels, this is a front elevation, these headlights, the wheels there. Sometimes the wheels also have springs. Wheels also have springs. And the vehicle also has springs of its own. Then there's a shock absorber in line with the springs. Otherwise, without shock absorber, the vehicle will be vibrating forever. The springs are meant to give it that comfort of vibration so that don't have a shock, have the problem. So we need to, string is supposed to do its own work to create that vibration, to follow the vibration itself. But sock will tend to control the vibration of the string for long and bring it to rest. So this is now the string constant, the sock has the B constant, and the force applied by the vehicle, the mass, is the force towards that. And if there's any kind of vibration, the distance covers, force covers is X. So that is what mechanical system we look at. The K, the B, and X and F. So it is moving in a straight line, the translational system. But if it is rotating in the rotating parts of the system, mechanical system, like the wheels, this could be driving the motor vehicle. There are many systems that must be driven by belt. This one can be driving the engine itself. This could be driving the one for charging the battery and control of the steering wheel. This could be driving something else. They are interconnected, but they're doing the same work of driving the engine. So transnational mechanical system. This system mainly consists of three basic elements: the mass, the spring, the dashboard, or the damper. The force is acting on the mass of the object, and the object now moves from, maybe accelerates, change of frequency, no change of velocity. But if change of velocity is constant, then that is there. Then we also have the spring, which is also supposed to have a constant and is based on force. The dashboard also is coming into play. Sometimes you can call it shock absorber. And at the same time, we have force on it. Let's question that manner. So a translational spring is a mechanical element that can be deformed by external force, so that the deformation is directly proportional to the force applied to it. Perfect. So if that is the thing for that spring, then the symbol for it in this. This is the spring in physical nature, but symbol for it in modeling, physical modeling is like this. So spring is an element which stores potential energy. So let's talk about the spring itself, with the force acting on it and is moving. Fingers of work want to join, but not really. Yes. Sorry. So spring is an element which stores potential energy and force is proportional to distance. And to bring that proportionality into equation means equating it with a cosine, there must be a constant k. You cannot call it R, P, K, W. Let me somebody here. Therefore, if that is the expression, the f of k, h in terms of k, is equal to kx. So f is equal to fk, which is kx. Where f is applied force, fk is the opposing force. Due to the elasticity of the spring, k is a sinking constant, and x is displacement. So when you talk about mass is an inertia element, a mechanical system without mass does not exist. If force F applied to the mass is displaced to x meters, then the relationship between the force and the displacement is given by Newton's law. Let me just look at the Newton laws before we go far, because it will be a disaster to talk about laws without telling you about the laws. Newton laws of motion. The first law is saying that every body continues in its state of rest or of uniform motion in a straight line. Every body continues to its state of rest or of motion, uniform motion in a straight line, unless it is compelled to change the state by a force to press on it. It will continue to move and continue to move forever, but can only change if there's some force applied on it to change. Then second law, the change of motion is proportional to the locomotive force impressed on it. So that force applied on is proportional to the acceleration. It's proportional to mass and acceleration is equal to mass and acceleration. The change of motion is proportional to the motive force impressed and is made in the direction of the line in which that motive force is applied, or force to mass is equal to product of mass and acceleration. Second law gives us that product. Then the third law, to every action there is an equal and opposite reaction. There's action and reaction are opposite. The action and reaction are opposite. There's a third law. So, if there's a mass and there's a force acting on it and you want to move the same direction, x, then force that is causing that motion is proportional to acceleration. And my equation is ma, the second law. Force is equal to Fm, and m is equal to the derivative, second derivative of distance, which is equal to acceleration. So that is how we have talked about the modeling of the mass in terms of distance it moves. So if as a mass, there's some object moving to a certain direction, this is the equation for that mass. And if there's a spring moving to a certain direction, this is the equation of that spring. What about the equation of a dashboard? A dashboard. If a force is applied to a dashboard B, then it is opposed by an opposing force due to friction or stiffness of the part. This opposing force is proportional to the velocity of the body, assuming mass and elasticity are negligible. There are certain things we must assume. So F of B is proportional to, what did you say? Velocity. The force acting on the transport here is proportional. If it is vibrating so much at high speed, this thing is going to be applying a lot of force to react heavily against that force is causing it. If the vehicle has been hit a pothole somewhere until it jumps up, you see, the impact will be so great. But we expect the dashboard to react proportionately with that force coming. Otherwise, it will break down the vehicle and will be a disaster. So, engineering has the fact that that dashboard is made in a way that it will react proportionately to any velocity that is acting against it, the speed, and it will be acting in that kind of relationship. So, F of B is equated to this equation, which is that. And this is a velocity equation in terms of distance. So the transfer function of translational mechanical systems, the first law, the first, the lowest, ringing still in my mind, no. The first thing you need to do draw a free body diagram. The diagram you've seen, you have to draw them, placing on the body all forces that acts on the body, either in direction of motion or opposite to it. So those forces must be drawn. So the second thing that you need to do in modeling, the coming up with transfer function, use Newton's law to form a differential equation of the motion by summing the forces and setting the sum equal to the zero. To sum it up, to wrap it up there, I don't know, where I'm staying, there's a lot of noise coming out. I don't know how you survive, but are you affected by that noise? Hello?
Hello, we are okay, we can hear you.
Okay, good.
Good to know.
Finally, assuming zero
So,
initial conditions, we take the Laplace transform of the differential equations, separate the variables, and arrive at the transfer function. I think this one you'll be taught by the Laplace transforms by Faris, Engineer Faris. Don't know that is taught you put on one. So assuming zero initial conditions, these are always given, but you assume it in the first case in all transfer functions that we start from zero initial condition. You're starting from the scratch. Maybe you say dy dx is equal to 0 at this time, at this point. So it will help you to arrive at the transfer function very well. Now let's look at the rotational mechanical system. This system mainly consists of three basic elements. Those are moment of inertia, torsional spring, and dashpot. These are dynamic systems also. What is a moment of inertia? In the translational mechanical system, mass stores kinetic energy. Similarly, in the rotational mechanical system, moment of inertia stores kinetic energy. So you can see this torque action, which is giving it in terms of the angle of the torsion. So the mechanical rotational systems moment of inertia proportional to this theta, the Tj is a constant J, is torsional moment of inertia with the acceleration. This is the acceleration. So T is also the opposite of the T, not acting against it, and the J with the angle derivative, second derivative, where T is the applied torque, yes, and Tj is a opposing torque, and J is moment of inertia, constant. This is a constant, moment of inertia. Then this is the angle of acceleration, the alpha. Then theta is the angle of displacement. So there are two different things. This one is just Tj alpha, this T alpha. This one should be enough separate there, just like this. And it gives that the torsional spring, if a spring, so this is just like saying that this thing can be rotated, this mass can be rotated at certain level. If there's a force acting on a certain mass to rotate it, Just like your body, you can be doing some kind of you're doing gym and you're rotating your body, and because your body is very flexible. Then there's a torsion. There's some kind of change. But now the spring, you also have spring which are torsional springs. But in translational mechanical system, spring stores potential energy, similar to the restriction of mechanical system. It stores potential energy. So Tk is equal to theta, because now it is not x. So Tk is k theta. So T is the third law. T is equal to Tk, which is equal to k theta. Where T is applied torque, Tk is opposing torque, K is a torsional spring constant, and theta is angle of displacement. The dashpot, when rotated with some kind of dashpot has a friction anyway. If a torque is applied to the dashpot P, then it's supposed by opposing torque due to the torsional friction of the dashpot. The TB is proposed to the omega, the angle, the angle angle. So TB is equal to B omega, which is B d theta dt, and T is equal to TB, which is equal to B d theta dt, where TB is the opposing torque and T is the applied torque. B is the torsional friction coefficient, there is the angular velocity, and theta is displacement. So this angular velocity can be expressed in terms of the theta, the T. Just like I think the alpha can be replaced with the theta. So here now we have a consolidated mechanical system with the dashpot, with the spring and the mass. So just like we said initially, that you start by looking at you start by draw free body diagram, placing the body in all forces that are acting on it, opposing and also not opposing. And second, use Newton laws for differential equations, and then finally sum them up and put them to zero. So consider this kind of arrangement. The free body mass, it is being acted upon in this manner. There's F is equal to Fk, Fm, and Fb. The force due to train, force due to the mass, force due to the dashpot. They are active forces. Fk is acting this way. There's Fm and Fm also. There's many F and Fm. So see how you're acting there. You can see F is here. So the transfer function here, there should be some kind of XX of FMX. So, okay, this equation here is just a summary of what's happening here. That in this arrangement here, you'll end up getting this transfer function. But it's not that simple. This arrangement here, you'll end up getting this transfer function. This arrangement here, which is got having two masses, you get this model. You end up okay. There are many areas that we need to cover, but all the same, what I want us to do as we close this morning session, this is the area. This is the area that we're looking at. This is the area where we are heading to. But we don't need to rush over this. If you rush over this, then you miss the point. We do it step by step until we get this thing. So I'll send these notes to you. Then I want you to do some kind of study on how this one, your average point, this point, and do it this one. This one is not indicated here, but this diagram, how will it give you a model for this free body? Then next time we meet, shall look at the electrical model and continue the same notes and see how we model this at the end. Then look at the analog systems, so on and so forth, and how the analog systems, how the mechanical systems are being controlled using electrical. Their model, this one becomes this one, this one becomes this. So that's where we are going to. But all the same, I want you to come back to these three. There's some notes which can give you direct. This is just a presentation, but I want you to come to this level. Please do me a favor, check the notes and get to this level. And when I come back, I'll explain effectively on this area because of time. Otherwise, I hope that's okay now. We shall be able to communicate and meet next week, same time. Are you okay?
Yes.